Greetings to you, ladies and gentlemen. We meet for the first time on a course, Mathematics 1, where we'll be looking today at numbers and operations. Our discussion will go further to looking into simultaneous equations or linear. We'll begin by looking at a few rules that we will be discussing on, but I've divided this presentation or this topic into two parts. The first one, we will be focusing on the BODMAS rule and how it is applied to mathematics. Then the second part, we'll be looking at the linear equations, where we'll be looking at how we can solve some linear equation systems, substitution, and by addition. Now, first things first. Let's look at what are operations. We have said we're looking at numbers and operations. Operations simply mean things like add, subtract, multiply, divide, or square. So anything that is not a number and we use it in numbers, we can say it's an operation. So those signs is what we refer to as operations. Now, for example, if we see a number like 7 plus bracket, opening bracket, 6 multiplied by 5 squared plus 3 closing bracket, what does that mean to us? Which part of that problem do we start working on or solving? Should we start by 5 squared plus 3? No. It means if different people were to look at it, somebody in the middle section, somebody from the left, somebody from the right, at the end of the day, we will get the same answer. The question is no. Having been faced by such a challenge, people decided to come up with the rules that we follow in mathematics. And one popular such rule is the BODMAS. Right. We have said every game has got its game. BODMAS, what does it stand for? It stands for brackets. The O stands for orders. Or it also stands for of, meaning of operations. Now, then we've said second is what? Order. It stands for order or orders. Okay. Then the D, you will find that in the BODMAS, the D and M, I've given them the same color. It's because when you are doing your calculations, you can either start with the D or the M. But what does the D stands for and the M stands for? Right. The D stands for divide or multiply. So you can even start by multiplication, then followed by division. It doesn't affect anything at all. Right. So in the order they come. If your problem has got multiplication at the beginning, then you use multiplication first in the order they come. The same with the AS, which stands for addition and subtraction. It doesn't matter what you start with, but in the order they come, the rule says if you are given a problem that begins with addition followed by subtraction, then you must begin by addition, then subtraction comes second. If subtraction in the problem is coming first and addition coming last, then you start with subtraction and add. So that's what we mean the add or subtract in the order that they come. Well, that's what we mean by orders in mathematical operations. The first B, we have said it's the brackets. That's what we mean. The O stands for orders. In the past, some think it's off, meaning we must remove the brackets. That's not correct. It simply means orders. And what are the orders? The square root and to the power of. Those are what we call orders. Or they also include, for example, 16% of 100. Those are what we call orders. Then division and multiplication, same color you can see. You can use them interchangeably depending on which one comes first in the problem given, so as the last one. So the order goes from brackets to subtraction. Well, having looked at that, let's look at a few examples that we'll quickly look at. Let's say we're given a problem 2 plus 3 multiplied by 4. We want to apply our BODMAS rule there. Okay? It means in this problem, the first thing that we are finding here is we've got addition, then we've got multiplication. Those are the two operations that we're having. But when you look at the BODMAS, the multiplication comes before the addition. So it means we must first begin by multiplication. We go to the pink second M there. Then it means we must take the first 2 as it is. We don't change it. Then we focus on the multiplication, 3 multiplied by 4. Because what is bound by the multiplication sign should be done first, right? Then, having done that, we can now go to addition, because addition is at the far end. It comes after multiplication, and our answer becomes 14. 2 plus 12 equals to 14. Well, another example. Let's say you are given 2 plus 3 multiplied by 4 divided by 2. Which one comes first? I know you have guessed it correct. Multiplication and division, the DM. D comes first there, but we have said these are not to be considered. You will look at the way the problem is arranged. In this case, multiplication is coming first, and division, that order, we will start by multiplication before we go to division. So the first thing is what? Multiplication. 3 multiplied by what? By 4. So what we do, we bring down the 2, which is not affected, right? And the other 2 for the division, because we're not dealing with that at the time being. We're dealing with 3 multiplied by 4, which gives us 12. So we multiply those 2 and we get our 12 in the middle. Problem. 12 divided by 2. Which one comes first now? We know it's the division, because division comes earlier than the addition. So we are going to add the 12. Sorry, it's division, yes? We are going to divide the 12 by 2 before we add. So we can just bring down the 2 first, because we are not dealing with it divided by what? By 2, and we get 6. Now we have got one operation, which is an addition. So we just add the 2 and we get our answer as 8. Right, quickly again, if we are given such a problem, 2 multiplied by 3 minus opening bracket 4 plus 2. Now, brackets off. Which one comes first? So we must remove the brackets. We deal with what is in the brackets, which is 4 plus 2, in order for us to take away those brackets, because B comes first. So it means the 2 and the 3 there in black, we should bring them down for the time being. Now, we deal with what is in the brackets, and we get a 6. We've got that problem now. 2 multiplied by 3 minus 6. And we know multiplication versus multiplication comes first. So we can bring down the minus 6 down, because we're not going to be dealing with that one. Then we now deal with the 2 times 3. That gives us 6. And our answer becomes 0. Well, so that's how we go on. Similarly, if we are given a number like 2 multiplied by 3 squared less opening bracket 4 plus 2, we say it's brackets order. Now we should deal with what is in the brackets. So the 2, the multiplication sign, and the 3 squared are not affected. So we must bring those ones down. Then we deal with what is in the brackets first, where we'll get our 6. Now, after B, we go to order. And the order in our problem there is the 3 squared. That's what we should do. We bring the minus 6 down and the 2 down. It's not affected. Then we deal with the 3 squared first. Okay? So we get our 9. Now, having arrived at that stage, what do? It's multiplication versus the subtraction sign. And what do? We are going to deal with the multiplication before the addition. So the minus 6 goes down as it is, and we deal with the 2 multiplied by 9 order there, which is minus. So 18 minus 6, we get our answer as 12. That's how we go about it. So similarly, if we're given such a problem, 25 multiplied by 4, right, divided by 48 plus 2. The 25, that bracket side, the line dividing the 2, it is saying what is the above, that is, it's in the brackets. That's why I have put the brackets there. The denominator as well, it's as good as it's in the brackets. So After putting those brackets, I put them so that we go back to our BODMAS. We deal with what is in the brackets first. So we shall deal first by multiplying 25 by 2 there at the top, brackets, and dividing by what is below. So that becomes our problem. We have rearranged it, okay? The first one is 100, the other one it's 50. We divide that, we get our 2. Okay? Now, I want us to go now to systems of linear equations. Now, let's look at what we mean. A system of linear equation consists of 2 or more linear equations that we must solve or deal with. Right. So, in 2 linear equations at a time. The solution of a system of linear equations in 2 variables is an ordered pair that solves both of the linear equations. Because we'll be having 2 variables in these 2 linear equations, and we must find solutions to those unknown variables. Now, we have got various ways of dealing with this, right? For example, minus 3 and 1. The minus 3 stands for the x, and the 1 stands for the y. We're talking of the x and y axes in this problem. So, we can simply say, for example, a system, the minus 3 and x is a point. But the system is made up of the equations now. For example, we're given here x minus y equals to minus 4, and we've got another second pair of 2x plus 10y equals to 4. Now, we need to plug in the values. What we're trying to do here is, we have said the point minus 3 stands for x, and 1 stands for y. We would like to try and substitute these points into x, we're going to put minus 3. Wherever there is a y, we're going to put 1. Then we see whether our equations, 2 equations, will remain the same. Okay, so in the first one, we've said x equals minus 3. We have replaced the x by minus 3. The 1 goes where y is, so it becomes minus 3 minus 1. And if we look, you'll find it gives us the correct answer, which is 4. So, if you look at the second one again, we've got 2x. Where there is x, we put our minus 3. So it becomes 2 multiplied by minus 3. I put it in brackets and in red there. Then the 10y, remember, we just take down the 10. And the y, where there is y, it's a 1. We put it there, and we see whether it will make sense. 2 multiplied by minus 3, it gives us minus 10. Will not change, it remains 10. If we are to add those two, minus 10 plus 10, it gives us 4. If you look at our second system there of equation, it means it's correct. So that point of minus 3 and 1 is correct. It satisfies both the 2 equations in the system. Now, since the point minus 3 and 1 produces a true statement in both equations, it is the solution that we seek. This is the basis of the simultaneous and the linear equation that we are dealing with. Let's look at another point, point 4, 2. That point, it simply means 4 is our x and 2 is our y, the coordinates, x, y coordinates. Now, the system, suppose we are given that system of 2x minus 5y equals, we have got 3x plus 4y equals to 4. What we're simply saying here is we're saying, okay, let me do this. Is that point true? Okay, let me do a bit of calculation here. Okay, so what we're saying here is we have got the 2 equations, right? Minus 5y is equals to minus 2. Now, we know wherever there is an x, it's supposed to be a 4. So here we shall put a 4 there. Let me make it a bit bigger. Okay. And where there is a y, it's going to be a 2. Now, If we are to rewrite this, it's the same as, okay, I'll put my 4 there, my 2 there first, and do this. Ta-ra-ra, ta-ra-ra, ta-ra-ra. Okay, I've got my 2 here and my minus 5 there. It should be equal to minus 2. Want to see whether it makes sense. This one, it gives us 8 equals, does that make sense? Yes, plus 8 minus 10, it gives us minus 2 equal to minus 2. So the statement is correct for the first one. If we look at the second one, okay, the second one, we want to find whether it, we have got 3x plus 4y is equals to 4. We know again our points, x is 4. So wherever there is an x, we are going to put 4. Right? Where there is y, we put a 2, and our equation will hold it true. We just bring down this 3 here. It becomes 3, the 4, still plus the 4. Is it correct? Now, this will give us a 12, okay, plus this will give us 8, and this one, it gives us 4. Right? Does this make, if we say 12 plus 8, it gives us 20, and 20 cannot be equal to 4. So it's not true. Let's see. Okay? So the first one, we said it's true. Okay? And the second one, it's false because 20 cannot be equal to 4. Okay? So, this being the case, that point is not correct. First equation, we found it 2, second wrong. Since the point 42 produces a true statement in only one of the two equations of our system, then it is not the solution that we want to our problem. Okay. There are various ways that we may use when we are doing linear equations. What I want to look at the different methods that we use. We have got the graphing method where we solve the linear equation using graphs. Okay. I'll skip that slide and we go to this problem. Let's say we are given a problem is given on the slide. We want to solve that problem using a graph. I've got it here, exactly that slide. Okay. Now, how do we go about it? We are going to try and graph those two linear equations, those two systems on this graph. Now, I want us to look first at the first one. Now, what we do here is we can easily find, assuming one of them is a 0. Now, let's say we take our x to be 0. We take our x to be 0. If we take our x to be 0, let me write it here. It becomes 2x minus y equals to 6. Yes, before we move to the next one. So if we take this one to be 0, then what do we remain with? It means we'll be having 2 multiplied by 0 minus y is equals to 6. This 2 multiplied by 0 is 0. So we only remain by minus y is equals to 6. Now, we want a positive y either side by a minus 1. Minus 1 multiplied by this, we also multiply this one by minus 1. So minus and a minus, when they multiply, they give us a positive. So we'll remain with a positive y. This side, which will be equal, but this side becomes negative, right? Negative 6. So what does this mean? If our x, we have said our coordinates are like this, and here it's represented by a, and the x is here and the y is there. So it means when our y is minus 6, our x, remember we've put a 0 here. We put a 0, so it will be 0. Now, if we were to go to our graph, the graph here, if we were to go to our graph, okay, we've got a point now, 0 and minus 6. If you look, this line is our y-axis. This one is our what? Our x-axis. Now, the point where x is 0, it's this one. 6. Y is increasing from here going up and decreasing going down. So here it's minus 1, minus 2, minus 3, up to minus 6. So the point where x is 0, x0, it's here, and y, it's minus 6, it's this one. 0, because we start here from 0, 1, 2, going, and 0 minus going this way. So this is our first point. So we denote it by a dot. Now, we try to look, right, that equation. Let's look at the other one, okay? Let's say we can play around with the same number and say, okay, suppose we say, we just pick it at random. If we say our x is, I want our x to be 3. There. Okay, here we are. So if we take our y, our equation again, it's 2x minus y is equal to 6. The idea here is I want a number that if I put here, it will also equal this number so that I can be able to cancel those numbers. So let me do it this way. If I take my x and make it 3, x make, then this I keep it as 2. Then here I'll remain y equals to 6. Here's what is happening. Why I did that? Because I knew this one is going to be 6. Right? So we remain with 6 minus y equals to 6. This is positive. Because for me to remain with a y, I can either take this y to this side, such that it becomes a positive y. 6. This 6, I'll take it to the other side of the equation, then it becomes a minus 6. So, if I move this 6, it crosses the equal sign, it becomes negative. So this side will now be 6 minus 6 is equals to my y. Now, here it becomes 0 equals to y, which means I now find what? My y. When my x is 3, so my points here, if y is 0, x will be 3. I hope that is clear. So, if I go again, having done that, and I go again on the graph, I can come and plot the same information on my graph. Okay, this is the point. Okay, when my x is 3, 1, 2, 3, when my x is there, what is my y? My y, it's 0 because it's starting from here, going up 0, 1, 2, 3, or 0 minus 1, 1, 1, going that. So my point will be there. All these 2 points, I got them using the first equation. So I can draw a line. I've got this point and this point. Then I'll take my ruler to join these points, and I get this straight line that is stretching from here going there. Now, having done that, I'll come again to the second equation, that one. X plus 3y equals to 10. X plus 3y equals to 10. Right. What we want again is to 0. right? If we make one of these a 0, okay, if I say y is equals to 0, what happens? Okay, what I'm going to do, it will not come exactly like what is there, but the answer will remain the same. Let's assume that we have taken x to be our 0. And already you can see a challenge that will happen if we take an x to be our 0, because we'll remain with the 3y, and our 3 will not go into 10 without leaving a remainder. So I prefer making y the 0. Okay, what happens if we do that? If I'll rewrite it here, it's x plus 3y is equals to 10. Now, we want to make y 0. Y, if I make y 0 here, it means we'll be having here 3 multiplied by 0 will be equals to 10 this side, and our x plus remain like that. And when that happens, it's good, because we can simply say x to 10. When y is what? It's 0. So our coordinates become, right, as follows. X and y is 0. Now, we go to our graph. What we'll do, we have said x is 10. Remember, x is 10 when y is equal to x. Here, we must go. Unfortunately, when you see, I've got a small graph here, but this line is to meet somewhere where x is 10 and y will be 0 somewhere there. Because here, x is, it's what? Y will be 0, I mean, where x is 10. X is 10 because 1, 2, 3, 4, we're going along x until 10 points. But y, you are not neither going up or down, because we'll be along this line to come to this mark. Okay. Now, here is what was done in this example that I did. Well, I first took a point at random and said, okay, what happens if I make y, right, x, I make a minus 5. Okay, I'm trying to find a number here that will give me, all right. I'll make my y 5, okay, and see what happens. Okay, I'll go here, let me cancel there, divide those. So I'll rewrite the equation again as x plus 3y is equals to 10. Okay, just a minute. Let me do this. Okay, equals to 10. Hope people are able to see. Okay, now I want to make my y a 5. So I'll say substitute wherever there is a y with a 5. These numbers, you can get them from the blue, right? Then what does it mean? I will end up with a 3 bracket 5 is equals to 10. And this side, I will be having x. When that happens, what? Here it becomes what? 15. 3 times 5, 15. Here, x. It's equals to 10. Now, what happens if I take my 15 side, because my x is already positive and it should remain a positive number. Therefore, I'll take my 15 the other side of the equation, where it will become minus 15, because a number, when it crosses an equal sign, it will change its number. So this side I'll remain with x is equals to, this one is gone, 10 minus 15, which gives us minus 5. Now, so the two coordinates again, remember, it simply means if x is minus 5, y will be 5. So if we go to our graph, I'll bring again this graph and say, when x is minus 5, remember what we have just calculated, x is minus 5, so it's this point. When x is minus 5, my y should be equal to 5. Remember this 5. So that point, I'll find it somewhere there. I'll look for minus, for x is minus 5. This is x. Minus, it means I start from here, counting this direction. And I go 1, 2, 3, 4, 5. Then I go, right? This is the minus 5. Then I look for the y. The y is positive 5. Then I count going up, because the y increases in this direction to this point. That becomes my second point. Now, I might take another number as well, because definitely I'll need that number, because I'll need two numbers in order to plot my chart. Okay, this time around, I'm going to take 4, 2 as my point. Again, it's a number that you can just get from the blue and see how it works on your equation. But the guiding principle here is, when we write these numbers, it should be that we should be able to eliminate one of the unknown variables. Okay, so I'll rewrite it as x plus 3y is equals to 10. Now, having done that, what do? I've said I'm taking 4, 2. It means where there is a y, I'm going to put this, that's where the 2 should be. Because we said our number is 4, 2. Right? Where there is an x, okay, for the time being, I will put a 4. Okay, let me see. First, you only need to find a number 1. My points are 4, 2 that I want to do. I want to put a 2 there and see what happens. Okay. Right. This one, it should not be changed, because you substitute 1 at a time. So it becomes 10. Now, this and this, it gives us what? 6. So x plus 6 should be equal to 10. Right. Having arrived at that stage, forget about this. It means if I take my 6 this other side, I'll remain on this side with x is equal to this. I'll have 10 minus 6. So if we net this, it will be x is equal to 4. It will be a positive 4. So my x is equal to 4. Right. X is equal to 4 when y is 2. So what does that mean? It simply means my point that I'm interested in on this graph, we've said x is 4 when y is 2. X is 4 when y is 2. Now, we take these points to our graph. When we go back to our graph, you see that the point where x is 4 and y is 2. X, we start from here going 1, 2, 3, 4, somewhere there. Then we go right. We mark it there. Then y is 2. It means we are going along y twice. 1, 2. So it becomes there. These 2 points that I've marked, okay, are all derived from, we got them from the second linear equation. Now we've got 2 points we can join. So when we join these points, right, from there going this side, and the first one that is going there, where they intersect here, that become our what? Our point that satisfies the system. So the solution using the graph, you go to the intersection point, then you what? You just see where they intersect. That's where your solution is. You can see that we could have plotted any number as long we could have just said, okay, what happens if x, okay, and what happens to 3y? It still works out to give us what we want. So that's how we work it out using the graph. So I'm just putting it back on the slide, what we did, the first line and the second line, and the intersection is 4.2. That becomes the point that satisfies our equation. So when given these 2 equations. Our solution is x is equals to 4 and y is equal to 2. Okay. Okay, ladies and gentlemen, we have looked at the graphing method where we try to solve linear equations using the graphing method. We've got the substitution method and we have got the addition method. I think we'll look at those ones next time. For now, I say have a good time. Thank you.